Welcome back, everyone, to Delta Y. This week, I'll be talking about, that's right, It's just me, Josh, this week, as Grayson's off on break, and we haven't figured out our remote recording yet, but we'll get that back to you soon, hopefully. So this week, I'll be talking about fossils from the Big Bang discovered with the W.M. Keck Observatory, an E-Bandage generating electricity that speeds wound healing in rats, a team that locates nearly all the U.S. solar panels in 1 billion images with machine learning, and a Mobius Kaleidocycle that could be used in chemistry to create a higher heat capacity, along with an ex-NASA engineer who created a glitter bomb trap for package thieves. Once again, this is Josh, and welcome to Delta Y. So the first article I'll be talking about this week is a discovery from the W.M. Keck Observatory in Hawaii. Now, what they discovered is a relic cloud of gas orphaned after the Big Bang in a distant universe, and they're calling this a fossil from the Big Bang. It's interesting to call it a fossil because usually we think of fossils as, dinosaurs or prehistoric animals. But this was, heavy elements exploding from the Big Bang. And these are still being found today, even, 1.5 billion years after the Big Bang. And what these elements are is they're very minuscule proportions to what we could find in our own solar system, and these distant elements are being emitted from a quasar. Now, these quasars are teaching these scientists that, some of these fossil elements are really rare and hard to find, but these fossil elements could be used for other things. Now, they first thought that these would be very hard to find, but, now it's possible to survey for these, and it's very interesting to see this because this is showing us that we're getting deeper into our solar system, and I shouldn't say our solar system, our universe, where we're seeing more and more about what we could discover. And this is showing what we've seen before. So this is all old, but, it takes a long time for light to travel. So we're not going to get imagery of some things even further away from pulsars or, even the Big Bang or, all sorts of cosmic events. Now, what these elements are, very, very small, obviously. But it's really showing that this could be the true relic of the Big Bang, where this could be the first, actual scientific evidence. I shouldn't say that, but it could be the first, hard evidence of the Big Bang, as these would be elements left behind from the Big Bang. Now, this is really interesting because, this is something that science has shown happens, and, it's an interesting way to think that, now we're starting to see these elements come out in, gas clouds, to see, traces of these elements. Obviously, this is something that we'll have to watch and see how it progresses, but I imagine it'll take a few years to start discovering more, because these were discovered, with a very powerful optical telescope on Earth. Once we start getting telescopes more out in space finding these, I think we'll start to find more of them. And it's obviously something to watch out for. Quick note I want to take in between articles here is that, this is going to be a much shorter episode because it is just me. I don't have that interaction with Grayson this week, so we can't have our talk back and forth. So I know you guys enjoy probably the longer episodes. This one's going to be much shorter, I'm sorry. I just want to preface that before we move into our next article, which is on E-Bandages. Now, I believe we covered this last week, but this was E-Bandage testing on rats. This was by the American Chemical Society, and it's shown that these E-Bandages, which are just electronic pulses, so they generate an electronic field over the injury, has dramatically decreased the healing rate on rats. And now this has been shown that it could be used for all sorts of different, stomach ulcers or non-healing surgical wounds, and just any sort of wound really could be using this sort of method. Now, they're using a wearable nanogenerator overlapping with. They're using a wearable nanogenerator. They're using a wearable nanogenerator that's using overlapping sheets of PTFE, and I'm about to pronounce this: polytetrafluoroethylene, copper foil, and polyethylene terephthalate. PET. So this nanogenerator converts skin movement, which is natural, during normal activity or even breathing, into small electrical pulses, which flows into this E-bandage. And there's electrodes placed on either side of the wound and it produces a very weak electrical field. But this very weak electrical field has shown, in rats to close a wound 75% faster than a traditional bandage. Now, this is really interesting because, a 75% decrease in the amount of time to heal a wound is incredible, especially for, people in, sports fields or, in the military, these types of, this injury reduction factor is incredible and could be very useful in the future to help heal people who are in high risk and high, dangerous situations. But more testing needs to be done. I imagine in a few years this will get approved because it isn't exactly going to be harmful. It's definitely more beneficial than any sort of harmful. And so I imagine within a few years we'll start to see human testing of this to make sure that, does the same concept apply? We do have very similar skin to rats, so I can imagine that this would also greatly reduce the time to heal in human patients as well. So, moving on to our next article, which was a team from, where were they from? Let's see. A team from Stanford University scientifically analyzed more than 1 billion high-resolution satellite imagery with machine learning, and they claim to have identified nearly every solar power installation in the contiguous 48 states. So, sorry, Alaska and Hawaii, not this time. But it's publicly available, and it looks like we'll be using this to go, because we're proving that people are going solar more than we think. So people are saying that, these images are showing that on average, they're finding that estimates from the census is not accurate to how much solar is actually available in the U.S. So that, we actually have more solar than we think we do, which, still isn't nearly as much as we definitely could. But the team trained their robot, which they named Deep Solar, to identify solar panels by providing it 370,000 images, which are 100 by 100 feet. Not the actual images, but what the images cover. And so they labeled them as either having or not having solar panel present. And Deep Solar was able to identify the features associated with the solar panel, which had to do with color, texture, and size. And they didn't tell it what was important, it just taught itself. So it was, it could find these solar panels 93% of the time and missed only about 10% of the images that did have solar installations. Those percentages don't add up, but that was what was quoted. On both times, it's more accurate than previous models and other ways to identify solar. And so, normally this type of thing would take years to find all the solar installations, whereas Deep Solar gets it done in a month. So what this could do is, it's not only residential installations, but also on businesses and utility-owned solar power plants. So, think of, I believe there's one in the Mojave, and there's a couple just scattered around the country, and there's more popping up slowly. They did skip a lot of the sparsely populated areas because they felt it was very unlikely that buildings in these areas would have solar panels, because they're not attached to the grid. So they didn't find that would be, a positive investment into the grid, which is what they're trying to find, is how much is our renewable energy affecting the grid. And this is really impressive, advancements for machine learning, showing that, they can adapt off-the-shelf systems to find what they need to find. And they're using these systems, these researchers, to, better aid in renewable technologies, to find out, how are we using renewables? How could we use them better? And how could we progress as a society with just renewables? So that's really interesting to see. It's from Stanford. This is really cool to see that they're able to find all these solar panels so fast, and that they're able to, so accurately find them compared to previous attempts. So our next article is on a Mobius Kaleidocycle, which is kind of a hint off the Mobius band, which is I'm sure a lot of you have made a Mobius band, whether you know it or not. It's when you take a strip of paper and you rotate one end of it 180 degrees and you put them together. You end up with a piece of paper that only has one side and one edge. But what this is a Mobius Kaleidocycle, which is a geometric structure that could be found in, you could look at a modern art museum. You can find them there a lot. But the motions they undergo is really interesting because they're connected with hinges, and they can be turned inside out continuously, kind of like a flower blooming over and over again. And so, you can think of this as you'd have a couple of hinges and it essentially invert itself every couple of minutes. But what they found is that when they create a kaleidocycle in this way, but they do it with this new technique, they found that a couple more folds and the understanding that if you create a Mobius Kaleidocycle, it's not going to have an end ever, right? So it would essentially be able to have no top or bottom, and it's formed, very interestingly, because it has, no top or bottom, right? I've said this a lot, but it could be used to function in self-propelled submarines or collecting water samples, as well as in chemistry. If you could synthesize molecules based on a Mobius Kaleidocycle, because friction is negligible on a molecular scale, these molecules could essentially rotate forever and have an extremely high heat capacity, because they have no end, essentially, is what they're saying. So you never have to worry about running out of the ability of a kaleidocycle in this way, which is really interesting because, you could lower your energy costs, and also if you're using this method to create a molecule, it's very interesting to see that, you're going to create something that has almost unlimited possibilities for use. And it may seem like I'm stumbling over my words on this one. I definitely am, because this is something new to me that I haven't really read up on much. So it may seem like I'm not very knowledgeable on it, which is very true. So I apologize for that, but I thank you for sticking with me on that one. But it's very interesting to see, that through mathematics and computer simulations, and using both paper and 3D printed models, they're showing that if they use angles just right, they're going to be able to make these that are free to move objects, and that they'll create, they have an endless movement structure where they don't have a beginning or an end. It's very interesting. And for the last article this week, it's our little funny article, we'll be talking about Mark Roper. He's a YouTuber. I'm sure many of you have heard of him. He's an ex-NASA engineer. And his recent video I wanted to talk about because it made headlines on a few news sites. So as of yesterday, when I was finding information for this episode, it looked like he had gotten he was up there on trending on YouTube, and he got 32 million views so far. And what he did was he took the Apple HomePod, I believe it's called. Haven't actually seen much about that. But he took a fake box, which he labeled with the addresses of the house from Home Alone. And he labeled it from Kevin, the kid, to the two guys who were trying to rob the house. And it's very interesting because when he was having package theft problems in his neighborhood, right? So he sets this out, and when someone takes it and they open it, it activates 4 phones, their GPS tracking systems, their cameras, and it also activates a little servo on top, a little motor, that'll spin, and it's filled with super fine glitter. And he also has another, cam system that's going to push down on a fart spray. So this thing spits out glitter, sprays a fart spray, and records the thieves in 360. And he can actually track them in real time to know where they are. And this is really cool because it's just showing, the type of people, that might steal these packages. But it's really cool. It's a great deterrent to kind of get people away from, possibly stealing packages. And it's just a fun way to do it, I think. In his quote, there's something that needs to be done to take a stance against dishonest punks like this. And this is kind of tying into our last week's episode where we talked about Amazon trying to track people who had been, taking packages in high crime areas. And so this is just another way I think this is a much more personal way to kind of get back at it in a far more an over-engineered way, but definitely a fun one. So that's all I got this week. Definitely a much shorter episode. I'm sorry about that. Hope you guys still enjoyed it. Be sure to check us out on Twitter. I do try to post there all the time about what we're doing, although I do miss quite a few weeks from time to time, especially during school, although I'm much better at now that I'm done with the semester and on break. And it's going to try to be more active on there. Go ahead and you can follow us on YouTube, which is where this will be posted. We're still trying to find a replacement for SoundCloud currently because we find that we were only able to upload 8 episodes before we ran out of space, which didn't seem right to us. So we need to find a new podcasting service. But YouTube's obviously just upload it as much as you want. So we'll be doing that for a while. And if you guys want to support us on Patreon, please do. We have one microphone. We have another microphone coming for Grayson. Obviously, we're going to have to figure out how to link ourselves together. And any support you guys can give us will be awesome. So anyway, that's all I got for you this week. And as always, I'm Josh. This is Delta Y, and stay creative.